Hello, East Tennessee, and welcome to More Living with Jim Brogan, where it's all about living the best years of your life your way. As you're listening to News Talk 98.7 WOKI, and you know, one thing that I've been excited about is the lunar landing that happened in February. I just think that's fascinating as we continue to explore. And, of course, that was a partnership between private and public because you had a private company partnering with NASA to do that. And, you know, it's kind of funny. You know, I'm 54 years old, and it's in the last 10 or 15 years that I've become very, very interested in just, you know, the world beyond our world that we live in here. Some of that is a good friend of mine that is really into astronomy and, you know, the science of our universe and our galaxy and everything. But it's just been astounding to me in the last 10 or 15 years in my journey. And, of course, we've got this solar eclipse coming up in April that was so amazing when we had that eclipse. I think it was 7 years ago in 2017, in August, I think it was. So just a lot of exciting things going on. And I know, you know, many of you, when you were kids, you looked longingly at the stars in the evening and wondered, you know, what else is out there? And since the beginning of the space race in the 1950s, humans have been working on ways to explore space. So we had the NASA shuttle program in the 80s and 90s, of course, to the privatization of space travel in the past decade. So we've made giant leaps out there, but there's still so much more we do not know about the galaxy and what is out there. Our guest this morning is Dr. Bradley Thompson. He is a planetary geologist and professor at the University of Tennessee. Dr. Thompson has endeavored to unravel the complex geological histories of our moon, our neighboring planets, Mars and Venus, using geological mapping and geologic analysis. So please join me. Welcome, Dr. Thompson. Great to have you on the show.
Pleasure to be here. Thank you so much for having me.
Yeah, it's great to have you. Let's dive right. I want to start with the lunar landing, and then I want to dive into your field of planetary geology, but what kinds of experiments were on board the lunar lander? The Odysseus. Did I say it right there?
Right, yeah. So it's Odysseus. This is Intuitive Machines, is the private company based out of Texas, and this was their IM-1, their first launch, Intuitive Machines 1s. So Odysseus is the name of the spacecraft, although they refer to it as OD for short. Yeah, I mean, it had 6 NASA instruments and 6 commercial payload elements, which is really interesting. So you mentioned the public-private partnership. I mean, that really has been, I think, a game changer for NASA, is leveraging the private sector. So, for example, Columbia Sportswear was one of their sponsors, people who make winter jackets and so forth, and they actually work with a company to develop a new type of spacecraft insulation. So if you look at photos of the spacecraft, they have this gold foil on a component of it and the big Columbia logo. And so they're actually doing this improvement of technology which could improve both the thermal protection of spacecraft, but I think also eventually improve jackets here on the Earth. So it's kind of a dual purpose endeavor.
You know, it's kind of interesting with the privatization because, you know, I've always felt like, man, the smartest guys and gals on the planet are at NASA. I've just kind of always felt like that. And there was that movie, was it Apollo 13, I think, yeah, with Tom Hanks, and, you know, how do we get a square peg in a round hole, basically. And I don't know, those guys are and gals are so smart, but yet we can be more efficient with our dollars with privatization, right? Is that a proper assumption to make? I mean, typically privatization can be more effective than public dollars.
Yeah, I think, you know, when you have competition, right, that's what really kind of pushes you. You know, you're always looking over your shoulder to see what the competition's doing. So, you know, if you're a single source provider in any market, right, that's a monopoly, and then I think you kind of lose your edge, you lose your push behind you. So the privatization, there's something like 13 companies, I think, operating in this sector now. And I think it's amazing that you know, the cost of IM-1 is about $110 million. And half of that is launch, thanks to friends at SpaceX. And that's a remarkable number to put that, to bring 2,000 kilograms down to the lunar surface is just amazing. And I think if NASA was to do it alone, it'd probably cost 5 times as much.
Yeah, at least. And there was actually some complication when it was landing, right? I mean, they kind of almost had an issue. Can you talk a little bit about that?
Yeah, so there was a very interesting briefing. So I just came back from Texas, from the Lunar and Planetary Science Conference, which happens every year in Houston, adjacent to the Johnson Space Center, a little ways north there. And the Intuitive Machines folks had a briefing on Thursday, and they talked about how there was a laser altimeter, so a laser pointer kind of on the side of the spacecraft that was supposed to ping the ground and tell them the elevation as they're coming down. And that component didn't work, unfortunately. So there was a small failure on that component. So they had to use optical navigation and IMUs, internal mass units, to make the landing determination. And, all things considered, they did a really good job. But it was supposed to land with a velocity of 1 meters per second, and it came down at about 3. But it's still, so, it was a harder landing than they would have liked. But the fact that the spacecraft essentially survived the landing, landed hard and tipped over, but still successfully had an operable payload on the lunar surface, I think is quite a remarkable accomplishment despite the setback.
And then the job of that, or part of that lunar explanation was to basically, we kind of beginning an era of commercial space mining, right? So talk about what one of the primary things, was with that lunar landing. Right.
So so this is part of a NASA program called CLIPS, so Commercial Lunar Service Providers, which is, again, this sort of small, we're growing our space industry here in the States, which is a wonderful thing. And so the idea is these launch providers are going to provide small, low cost missions to the lunar surface to deliver scientific payloads to various places that NASA and customers want to go. They're doing lunar geology here. They're doing comms demonstration. They demonstrated, what else did they demonstrate? That was one of the big ones was communications. I mean, this was basically like a test run for later flights, but we've also landed further south. So most of the landings have been around the equator because that's the easiest to get to on the near side.
And this was it at the South Pole?
Yeah, this was pretty close to the South Pole, 5 degrees away, which is a much more challenging thermal environment, much more challenging lighting environment. And so this is, I think, viewed as kind of a precursor to follow-on missions, including Artemis, which will land people there in the not-too-distant future.
So what things could be mined, say, on the moon, other planets, even asteroid? What are the consequences of space mining?
Yeah, so resource utilization is a big buzzword at NASA. So the one for the moon is water ice. So we have good evidence from neutron spectroscopy, so from measuring neutrons that are emitted off the lunar surface because of cosmic rays, that there are deposits of ice near the north and south pole of the moon that are mixed into the regolith, mixed into the lunar soil at kind of a low abundance, sort of 1 to 5%. But that's enough ice to mine commercially, and then you can do all sorts of fun stuff with it. You can make rocket fuel. We can use it to drink, to sustain human presence, to grow food, all sorts of fun stuff. But so the future of human exploration in cislunar space, in the area around lunar space, is really going to be dependent on resource utilization of this polar ice.
Wow, that's Dr. Bradley Thompson. He's with the University of Tennessee. He's a planetary geologist and professor. We're discussing the recent lunar landing, and of course we got the eclipse coming up, so we're talking about a lot of fascinating things. When we come back, Dr. Thompson mentioned maybe not too far in the distant future, we get people going back to the moon. What could we have a lunar base at the moon? Would it be at the South Pole? What are the ramifications of all of that? So how close are we really to having people at the moon for periods of time? Stay with us. This is More Living with Jim Brogan here on News Talk 98.7 WOKI. Welcome back to More Living. This is News Talk 98.7 WOKI. I'm your host, Jim Brogan. We're visiting with Dr. Bradley Thompson. We're talking about our solar system as we just had the lunar landing in February. We've got this solar eclipse coming up in April. Space is the final frontier, and I know many of us have always had such a fascination of space. And Dr. Bradley Thompson is a planetary geologist and professor at the University of Tennessee. You mentioned people on the moon. So talk a little bit about, you said maybe the not too distant future. What do you see in terms of our exploration to the moon?
Well, NASA's very serious about going back to the moon, right? So the Apollo program ended in 1972 after a series of missions between 1969 and 1972. And now we have the Artemis program, which is, they've already had their first couple launches there, testing out all the equipment that'll loop back past the moon. And so Artemis 3 will be the one that will carry people to the lunar surface, and it's currently slated, I think, it's gotten pushed back a little bit, so I think maybe 2025, 2026, something in that time frame. But it will bring a crew down to the surface of the moon. They'll operate there near the South Pole, operate there for 6 days, and then return to their spacecraft and then return to Earth. And they've already picked the Artemis astronaut selections have already happened. So there is, for the listeners, there is a call for astronauts currently open. So if you're interested, you can apply to be an astronaut, but it'll be for some of the later missions down the road, I think.
So they'll be on the moon surface for 6 days.
Yes, something like that.
That's wild.
Yeah.
Where do you see that going? You think in terms of having a lunar base, you see we could be having people go there in 5 years for 3 months?
That's entirely possible. I think that it could unfold something like the Antarctic program we have today. So we have a base down in the continent of Antarctica, which is in the South Pole of Earth, and scientists and others can go down there for stints of a few months, 6 months, a year, and it's all sorts of folks, right? It's not just the science types like myself. There's also, we need mechanical engineers, people who can fix stuff because a lot of stuff breaks down, you name it. We always need a good cook wherever you go. I think there's going to be a big community that'll eventually grow from this. And that's the big debate now is, okay, so we got Artemis 3 is going to go somewhere near the South Pole. Do we send the Artemis 4, 5, and 6? Do they go back to the same place and try to establish a lunar base? Or do we try to shift around and explore more of that lunar environment? And those decisions are still being made today.
Now, you mentioned up till now the landings have been mainly around the equator of the moon.
Right.
This was on the South Pole. You're saying that our exploration is going to be back to the South Pole when we go back and land people on the moon. Why the South Pole? Is it because we see ice there?
Right. So unlike the Earth is tilted about 25, 26 degrees, and the moon is almost straight up and down. So it means that if you're in a crater, if you're in a hole near the north or south pole of the moon, the sun never shines directly down into that depression. It kind of scoots around the horizon. And as a consequence, it's very, very cold, more than 110 Kelvin. So cold enough to condense volatile species like water, like other stuff. And so it's in these cold traps that if there's cometary impacts or maybe solar wind implants over time, we think that there's accumulations of polar ice over the hundreds of millions to billions of years that these places have existed in this environment.
Now let's talk about, Dr. Thompson, your neighboring planets, Mars and Venus.
Yes.
How different are they than the Earth, and what are areas, we think of them as being very different, but then where are there areas of similarity, or are there any?
No, there's both, right? So that's a good question. So with Venus, if you go out from the sun, if you got Mercury, Venus is like your oven if you turned it all the way to that bake setting, right? The surface is something like more than 800 degrees Fahrenheit, so it's hot enough to melt lead. And this we think is a runaway greenhouse. So if we don't do something about climate, eventually the Earth will heat up. I don't think it'll get quite as bad as Venus, thankfully, but it will get very uncomfortable, especially those of us that live near the coasts. But yeah, so it's a runaway greenhouse effect. There's no oceans, no water on Venus, and we're not going to send people there anytime soon because they would have a very unpleasant and short trip to the surface. Mars, on the other hand, so now we're moving past Earth, further out towards the outer reaches of the solar system. That's the next one, and it's long been a topic of fascination for those interested in science fiction. So there it's a different case. The atmosphere is 1/100th that of Earth's. It's very thin, tenuous, and there's interestingly evidence of former liquid water on the surface. So again, water's part of the story there. And we've got robots currently roving all over the surface, exploring, checking out geology, studying what it was like in the past. But there is definitely a plan so that currently NASA wants to do moon to Mars. The idea is we're gonna focus people first on the moon and develop technologies there that'll help us bring people to Mars. And
yeah, it's fascinating.
And
we had one of your colleagues on the show, recently about the rover Perseverance,
right,
and NASA's Mars mission program that launched in 2020. Can you give an update? Give us an update on how that mission's going.
Yeah, so that was Professor Linda Kay. Her and her students helped drive the rover on Mars, which is pretty cool.
Pretty exciting, yeah.
Yeah, you can be a student and help steer this rover. So it's not drive-by-wire, right? There's hundreds of engineers and scientists who program commands that all get bundled together and transmitted to the spacecraft. But it's exploring Jezero Crater, which has an interesting delta, which is a place where a river dumps sediment into a larger lake basin, a former lake basin that's now dry. And there's all sorts of interesting sedimentary geology there. So, and what that rover is doing is collecting little drill samples, so kind of pencil-sized drill cores, and it's documenting the environment that they're collecting them from. And I think it's collected 17 or 18 of these little drill cores, and so it's holding some of them on the body of the rover and then depositing some of them on the surface for a later rover of some type to come and pick them up and bring them back to Earth.
That's pretty wild.
It is, and unfortunately, it's expensive. So that was the talk this past week. Is Mars sample return has been this 30-year objective for the Mars science community, and unfortunately, it is quite expensive to do right. So NASA is very very much in the throes of trying to wrestle with the budget for how to keep that under control, but still balance this wonderful other portfolio of stuff they're doing.
You know, it's funny. We call Mars and Venus our neighboring planets. But it's kind of crazy, really, how far apart we actually are. Can you give us a perspective on that? How long does it take to travel from the Earth to Mars or from Earth to Venus? That's
a good question. So let's see. So let's start with the Moon, actually, because that's a 3-day trip, right? So you launch from the Earth. You got about 3 to 5 days to go to the Moon, and then you can do lunar.
And then give us an idea of the speed at which, once you get into space, the speed at which you're traveling.
Oh, you're traveling many times the speed to get a parking ticket. So I actually don't know what the delta V would be. That's an excellent question. But you're moving at tens of thousands of miles an hour. So as fast as our current rockets can boost us, and then you got to turn around and decelerate. But it's about a 3-day trip to the Moon. Whereas Mars is far enough away that there's only a launch window every 2 years. The orbits are in phase, and it's a 6-month journey. So that's a lot longer time to spend in your tin can going to Mars than going to the Moon. So 6 months versus 3 days. Now Venus is more complicated still. It's actually harder to get into the inner solar system because of the nature of celestial mechanics, and the time travels there are of the order of many months to even years, depending on the exact orbital trajectory, how many flybys you do to give you gravity assist to get you to spiral into Venus.
And with Mars, we just have this window of opportunity every, I think you said 2 years, because based on our orbits.
Yep. So every 2 years, countries, not including just the U.S., right? So China, ESA, other countries are launching stuff. And that's actually one of the exciting things, going back to the Moon. So yes, the U.S. just landed here with Intuitive Machines 1. The Japanese landed a spacecraft, SLIM, earlier in January. And like us, they also encountered some landing difficulties. They landed upside down, but were still able to deploy a little rover to scoot away from the spacecraft, turn around and take a picture of the lander. So yeah, it's quite exciting in the lunar sphere that there's so many countries, friendly competition, friendly competing to land stuff in the lunar surface.
How much collaboration is there?
A fair amount.
I would think a good bit. I mean, there's a lot of collaboration with the space station. I would think that translates over into this.
There is, yeah. So the International Space Station welcomes partners from ESA, even from Russia and other countries. The one country that we don't play quite as nice with is China. So there's some specific restrictions.
Shocking.
Yeah, on sharing technology. We don't want technology that we spend a lot of money on to diffuse to China. So we more operate at a distance with China, kind of observing each other, but
kind of more race against each other a little bit too.
Right. So the South Koreans have a mission now around the Moon that has a very interesting contributed U.S. instrument, ShadowCam, which is taking pictures of these dark lunar craters and looking at them with scattered light. So there is, there is definitely a partnership between U.S. and many other nations.
Yeah. This is Dr. Bradley Thompson. He's professor at the University of Tennessee, a planetary geologist. And I have to say, I'm very, you're obviously a very intelligent guy. And, I mean, you're a scientist.
Sure.
And, but you do a great job at, like, I've noticed whenever you say something, you always back up and qualify for us exactly what that is or what that looks like. You're very good at relating it to a listener who's not a scientist.
Well, one of the fun things we get to do at University of Tennessee is we teach classes both for our graduate students and our advanced students, but also intro students. So I teach Intro to Planetary Geology. It's a 100 level course for majority non-majors, and for most of these students, this is the last science course they're ever going to take in college. So I view that personally as a huge responsibility to give a little bit of earth science and space science.
And opportunity. And
opportunities, yes, absolutely.
I would think some people take that thinking it's going to be their last science class, and it creates a new frontier for them in their education. A
little spark, sure. And a lot of the techniques and tools that we use in planetary, of course, we use them on the Earth all the time. So satellite observations of crop health, of forest fires, of all sorts of things, of weather, all the weather satellites that we have, that's sort of outgrowths of the space race. Our ability to track hurricanes before they get to where they're going. All of that is in some sense a product of this space race and wonderful endeavor that we get to participate in.
So planetary geology, give our listeners an idea. What is planetary geology? How did you get interested in that specific specialty in the field?
So planetary geology is, geology is, the root of it is study of and Earth specifically. So planetary it's a contradiction in terms, right? Because it means up there, down here, right? So other planets are like the Earth, and it's really a comparative endeavor where we compare the processes and landforms that we see in other planets to those on the Earth. And they're very different environments, but we can make some connections. What was the second part of your question? I lost.
I guess, how did you get interested in that specialty?
How did I get interested into it? I was interested in lunar geology, and I was under the mistaken impression that it was astronomers who were in charge of NASA. And don't get me wrong, there's a huge component of astronomy in planetary science, but astronomers spend a lot of time looking through telescopes at stars, and that's all well and good and interesting, exploration of the universe. But if you're talking about boots on the ground, dealing with actual rocks, things astronauts are going to touch and feel and encounter, that's geology. That's not astronomy.
Sure. Astronomy, though, gives us the ability to look, and with some of the technological innovation there, with the way we can see things. Oh my goodness, it's just opened up so much in the last few years to open up our minds of what's just some of the things that are out there.
Absolutely. What has revolutionized recently is these cell phones, right? The miniaturization of technology allows student groups to put together payloads to launch on space missions. So, for example, there was a group here in town that put together a payload, a high school group here in Knoxville that launched a small payload up to the ISS with NASA's help. So it's amazing that groups of even secondary students can assemble commercial off-the-shelf technology and put it up there. And I think that's one of the most exciting things, that it's not just NASA, right? Now we're in the era where there's all sorts of opportunity for students, for young people who are interested in this type of stuff to get involved as engineers, as scientists across the board. It's a very exciting time.
It is exciting. We're visiting with Dr. Bradley Thompson. We're talking about our solar system. We come back, we're going to talk about how we're moving forward with lunar and planetary science. We're also going to talk about the upcoming eclipse that will be very excited. Of course, we had great seats right here near Knoxville, Tennessee 7 years ago in 2017. This one will be even a larger eclipse that lasts longer and covers a bigger swath across the United States. But when we come back, we'll also have our dollars and cents segment. Might we see a limitation on your ability to add money to your 401k or your 403b or other retirement account as we look at some of the new tax proposals that are coming out of the White House and out of Washington? Stay with us. This is More Living with Jim Brogan here on News Talk 98.7 WOKI. Welcome back. This is More Living here on News Talk 98.7 WOKI. As we're visiting with Dr. Bradley Thompson and talking about our solar system with the exciting developments on Mars. Of course, we had the lunar landing last month. We got the eclipse coming up in April. Before we get back to Dr. Thompson, however, it is time for dollars and cents. President Biden's latest budget proposal may limit your ability to save money in retirement accounts. So let's talk about this a little bit and why we should be paying attention to this. Back when ERISA was passed in the 1970s, that created IRAs, individual retirement accounts, which provide us with the ability to save money on a tax advantage basis to supplement retirement. And the whole idea was, hey, so at the time, people were worried about the solvency of Social Security. Doesn't this sound familiar? And so they thought, well, we want to encourage people to save on their own and not just depend on the government and Social Security for their retirement. So they wanted to incentivize us. The Congress did when they wrote the Internal Revenue Code. When they wrote ERISA, they wanted to incentivize us to save money for retirement. So they gave us tax advantages. Well, now with our budget, and we've got $34 trillion debt right now. We have huge deficit spending. Nobody I talk to is not worried about the current issue with our deficit spending and our ballooning debt. And so how do we get our arms around that? Well, one of the latest proposals, again, under President Biden's newest budget proposal, is they would start to limit our ability to save money. Now, it would initially be for the wealthy. Limit the wealthy people's ability to save money in a 401k, a 403b, or other company plan. So remember your IRA, your 401k, your other retirement accounts, everything except for Roth, very little, if any of that money's been taxed for income tax. So you've got this big buildup, this big income tax time bomb, if you will, that's built up in there. Well, the government wants you to start paying off the taxes on it. It's like you have this big IOU to the IRS. And so right now, when you turn 73, you have to start taking some distributions. Well, the IRS is now, President Biden, they're wanting to limit how much you can accumulate in a 401k or other company plan like a 403b, a 401a, a 457. It's a whole alphabet soup. Now, right now, the budget would limit you that once a 401k or other company plan gets to $10 million, anything over that, half of it would have to come out every year and be taxed. Now, you might say, well, Jim, not a lot of people have money, over $10 million in their 401k or their 403b. And that is true. And I'll kind of draw back to when there were proposals that would eliminate the capital gain incentive for investors that make over $1 million a year. Because our Internal Revenue Code gives us incentives to invest in that. Long-term capital gains have very, very advantaged tax rates. But here's why you should be paying attention to that, even if it doesn't affect you now. Once it goes into law, once the government says, here's a group of taxpayers who are not eligible for these tax benefits that everybody else is eligible for, how long is it before it starts filtering down and affecting more and more people? What was Milton Friedman said, there's nothing more permanent than a temporary government program. And if you go back to the Income Tax Act in 1914, our highest income, you had to make $3,000 in 1914 just to pay any income tax. Well, not many people in 1914 made $3,000. And then the tax rate was 1%. Well, look at what we have now. So we've got to pay attention to these things, because once we start carving out a group of taxpayers and we start saying, okay, you're not eligible for this stuff, then I think that can be very dangerous, because does that eventually filter down and affect you and me? And retirement accounts have been discussed more and more, not just by the president's administration, but by other congressmen and women, as being on the chopping block to start accessing and limiting our ability to save on a tax advantage basis. So always be paying attention when we get things that wouldn't affect you today, but is it opening up Pandora's box and may affect you tomorrow? Please check us out at broganfinancial.com. My next class is actually at Pellissippi State Community College through their adult education and community outreach. It is income planning for retirement. It is a one-night class. You know, my main classes that I do both at University of Tennessee's adult education and at Pellissippi are two-night classes, but this is a one-night class specifically on the challenges of income planning, which I think is the most overlooked area in retirement planning today. That's how much can you draw? How do you structure your investments to support your income? How do you fight inflation? How do you reduce income taxes on your retirement income? If you'd like more info, the class is on Tuesday, April the 9th at 6:30 p.m. It's a 2-hour class, 6:30 to 8:30 at the Hardin Valley location campus. So you can go to PellissippiRetirementPlanning.com, PellissippiRetirementIncome.com. That's PellissippiRetirementIncome.com. You can download a syllabus, click to register. We'd love to see you there. Again, that's Tuesday, April the 9th, Income Planning for Retirement. Today we're visiting with Dr. Bradley Thompson. We're talking about our solar system as we had the lunar landing last month. We've just got so much going on. We got the mission to Mars with Perseverance. We've got a solar eclipse coming up as well, and I do want to talk about that briefly. I know that's not geology. I guess that's getting more into astronomy.
Yeah, a little more astronomy,
Okay.
but it involves the moon, so there is geology.
It does involve the moon. So, it was unbelievable 7 years ago. I'll never forget. We actually, myself and several of our friends, we actually got in a boat and we went downstream almost to the Fort Loudon Dam.
Okay.
And so we were near the center of that thing. We got over 2 minutes of 100% eclipse.
Totality, yeah.
Of totality. We got over 2 minutes, and I think the maximum was around 2.5 minutes if you were right in the dead center, so we were pretty close to that. But to put that in perspective, the one in April, I think it's like 7 minutes.
It's going to be
a lot longer.
Yeah.
Now, of course, it's not coming through Knoxville.
Unfortunately, no.
But can you talk about, And I had friends like in Charlotte, North Carolina, and other areas that were like, yeah, we saw like 98%. The difference in seeing 99% in totality, until you've seen totality, I can't imagine you really understand what that's like.
Right. I mean, so partial eclipses are fun because they go on for quite a while, right? So you're talking hours where the moon's taking a bite out of the sun, and you can see that march across the surface. But totality, I mean, as you said, right? So, if you're here, like that was a very warm day, right? That the one in 2017, and you could feel as soon as that lunar disk covered up the sun entirely, the temperature dropped, right? It was like twilight. It dropped like 4.
And the cicadas started going.
Like
it was unbelievable.
Birds started chirping, right?
Yeah, they thought it was not evening, dusk.
About what time it is. And it really is a immense experience. And then you can see these wonderful tendrils around the sun that you don't normally get to see, as long as you have your eclipse glasses, of course, so you don't damage your eyesight as you're looking at the sun. But it is really an amazing thing to see, and it's quite a remarkable coincidence. I mean, there's no reason why the moon and sun should be the same apparent diameter in our sky. It's just
it's pretty wild, isn't it?
Wonderful happenstance, yeah.
Yeah, with the whole. Well, it just kind of gives you an idea of how far away the sun is. It's so much bigger than the moon.
Right.
So it does give you an idea of how far away that is for those to be covering up the same kind of space.
Right. So the moon is
where we.
Yeah, the moon is 1737 kilometers in diameter. That's a number I have burned in my brain because I'm a lunar scientist. And the sun's about 10,000 and change. So yeah, quite a bit different.
Yeah, it is. It's just amazing. So, and that's on April 8th, by the way. Of course, you can't see that from Tennessee. That comes up through Texas, goes up through Ohio, I think parts of Pennsylvania, western New York.
Yeah, Buffalo, Montreal, I think will be the biggest city. Our friends in Canada will get a pretty good show. But yeah, everything from I think Dallas and Fort Worth are going to be in the path of totality. Yes. Little Rock, like you said, some places in Ohio.
Well, it's interesting because a couple of years ago, or back in 2017 when it was over, I mean, to see totality, I mean, it was awe-inspiring. It really was, for me anyway. And I was like, we are going in 2024. Well, now we're here, and I haven't planned a trip. And I had always planned on like doing a week. It's on a Monday, I think. Yeah, it's Monday, April the 8th. Okay. And I had always planned on like doing a camping trip, like, hey, we'll go somewhere, rent an RV. or maybe just a pull-behind trailer at a campsite. But, that's the day of the championship game in the Final Four.
Oh, dear.
And I'm like, do I really want to book that trip? Because what if Tennessee actually made it to the Final Four and to the championship game? Because Tennessee's never been in the Final Four. And I know everybody's disappointed with what happened yesterday. You got to have faith. I think this is a year they may have a real run. But that's not what we're talking about today. We're talking about our solar system and the exciting things out there. So stay with us. We're going to talk about the power of this public-private partnership to achieve a goal. We talked a little bit about that in the first segment with our space exploration with Dr. Bradley Thompson. So stay with us. This is More Living here on News Talk 98.7 WOKI. This is More Living with Jim Brogan, where it's all about living the best years of your life your way. Thanks for tuning in this morning to News Talk 98.7 WOKI. You can catch us every Saturday, 9 to 10 a.m., again from 3 to 4 p.m., and you can catch our podcasts. They come out Tuesday afternoon. This show will be on Tuesday. You can either go to my website at broganfinancial.com and click on radio, or you can go to Spotify, Apple Podcast, type in More Living. You can pull it down. We just try to have a lot of great experts and a lot of great guests that can talk about things that are just really help us embrace life and live life to the fullest. As today we're visiting with Dr. Bradley Thompson, we're talking about our solar system as we had the lunar landing last month. We've got the solar eclipse coming up next month. Of course, we've got the exploration to Mars that's still ongoing. And of course, Dr. Thompson, you're a planetary geologist, and you just attended a lunar and planetary science conference this week.
Right.
And got back late last night. Thank you for coming into to the studio today.
Wouldn't miss it.
We really appreciate it. What were some really exciting discussions or discoveries revealed?
Let's see.
Like what stands out in your mind? A couple of things. You mentioned Perseverance, which is the Mars rover that landed in 2020. There's actually the one prior to that, the Mars Science Laboratory, Curiosity, which landed in 2011, 2012. It's been trundling up this very interesting place on Mars in Gale Crater on Mount Sharp. There's a mound of sediments that are layered, and it's been slowly making its way up, and it's getting really close to this interesting transition between a mineral phyllosilicates to sulfates. They're two different alteration minerals, and we think they capture an environmental transition in the past on Mars. So we've been itching to get to this place for the past 10 years, and the rover is finally on the cusp of getting there. So they're doing long-range imaging and trying to plan their route as they've been doing for years. Hey, can you back up and explain that a little bit with the evolution of what you were saying there with the...
Yeah, so the environmental transition. So
the environmental transmission.
So if you look at Mars today, there's evidence of water in the past. So there's dry riverbeds, places that look like water flowed on the surface, carved, much like we have here in eastern Tennessee, a lot of water carved activity. But they're dry currently, so there's no water on the surface currently. So at some point, Mars had water and then lost it. So it underwent what we call this great drying at some point in its past history. And it's a big mystery exactly how this happened. Mars is smaller than the Earth, so it has less gravity, less able to hold on to its atmosphere. So we think a lot of this water was lost to space. But the timing of this specific transition, we think, is captured in the sediments within Gale Crater, where the Mars Science Laboratory Curiosity is currently roving.
Well, that's very exciting.
Yeah. And then you've got everything from that to the Hayabusa samples were returned, so samples coming back from asteroids. The samples that OSIRIS-REx returned from the asteroid Bennu. This made the news a while bit because we couldn't get the box open, so it was sealed in this container. And the joke was, how many scientists does it take to open a tin can? It turns out all of them. But they finally got the thing open and have interesting samples in hand after a several million-mile journey.
It's remarkable to me, and this is what's really gotten me so fascinated, especially in the last 10 years. Now, this gets a little bit more into the astronomy world, but there's certainly some geology in there, too, because when you think about all the things that had to happen for us to be here today,
right?
And the way, you look at the Ice Age. If that asteroid doesn't hit in the right spot and be the right size that cause a cooling period for the exact length of time it did, we may not have the conditions that we could even be here today.
Yeah,
so it's just remarkable. And so then when you start talking about dry riverbeds on Mars, that's what that makes me think of. I mean, because it's remarkable.
Sure. And the wonderful thing I think about the current era of space exploration is, so we don't have a frontier in this country anymore, right? So you can't just pull up stakes and be like, oh, I want to go out west or, move up to some new place. It's getting harder and harder to do, right? As we occupy more of this planet. But luckily, there's still a lot of real estate out there in space where entrepreneurs can start companies, can make a business case to operate in this space environment in a way that it just simply wasn't possible even a couple decades ago.
Now, you've developed numerous pieces of custom-built software.
Yes, sir.
And that really helps facilitate research. Talk about how that can help us grow in our research about other planets.
Yeah, so I use mostly a program called MATLAB, which is put out by a company called Mathematica out in Cambridge. But I think a lot of scientists do similar things in that they make little bits of software to help them in their own work. So in my case, for example, back in 2011, we had mission data we were returning from the moon. So I'm a co-investigator on the Lunar Reconnaissance Orbiter instrument, MINI-RF, which is a radar instrument taking radar images of the moon. And it returns these radar pictures. And I had to figure out, okay, what are the four corners of these images and where does that footprint fall on the moon? So I wrote software to go through the archive, pull out these corner coordinates and make little footprints in a GIS, in a geographic information system, to help us better find these data. So things like that. So little pieces of software to help us gather data and redisplay it in a new way. I also wrote a small program to interpret grind data from the rovers. They have these little grinders on them that help clean off the surfaces of rocks. And so we developed software to interpret the energy consumed in that grinding and try to relate that to how strong the rocks are. Because it turns out if strong rocks take more power and weaker rocks, it just rips right through them.
It's exciting stuff, and we're actually out of time. I hate that we're out of time. We've just talked about a lot of exciting things. Of course, we got exciting things coming up. You said next couple of years we expect landing people back on the moon. That's pretty dang exciting. So, Dr. Bradley Thompson, thanks so much for taking time out of your very busy schedule, coming back from a conference, come straight into the studio. Thank you so much. We really appreciate it.
Thanks, Jim. It's been a pleasure.
Absolutely. We've discussed the final frontier. Because the more we understand, the more we can explore, the greater we can understand really everything about life, and that can provide for more living so we can live the best years of our lives the way we want to be living them. So much thanks to Dr. Bradley Thompson from the University of Tennessee. Thank you to Jennifer for engineering the show. Thank you to Jill for helping produce the show. Be sure to check out my upcoming class on Tuesday, April the 9th, Income Planning for Retirement. That is through Pellissippi State. You can go to PellissippiRetirementIncome.com. It is on Tuesday, April 9th. 6:30 to 8:30 p.m.
And that's one day after the eclipse, so good timing.
It is one day after the eclipse. It is great timing. If I go to the eclipse, I'm still going to make it back to teach that class.
Excellent.
Thank you for listening this week. Have a very, very blessed weekend. This is More Living with Jim Brogan right here on News Talk 98.7 WOKI.